Now let's solve our second question, which is just a limit question actually. So we have a limit of the integrals. When you put zero or around zero, this becomes zero, right? You can put it. When you put zero, they are equal. So let's analyze the undetermineds of this limit. Above is zero. When you put zero, cosine zero is one, so the integral is vanishing, right? When whatever you have ft dt, if you have the same boundary, it is always zero. Okay, so that's why denominator also zero. Okay, so we can apply L'Hopital rule because by fundamental theorem of calculus, everything inside is positive, which by the theorem of fundamental theorem of calculus, it is differentiable, so you can take the derivative, right? So L'Hopital so limit. We don't know the limit will be exist or not. That's why I'm not equating. I'm just applying L'Hopital rule. X goes to zero. So this part is zero, which is a constant function, right? So this is a function in terms of x. So we can apply L'Hopital rule, fundamental theorem of calculus, which will have minus, let me put because of this minus, uh, sine, instead of t, I'm going to put x squared, x to the power 4, dot the derivative of x squared, which is 2x. Okay, minus the derivative of the boundaries, which will be 0. That's why I'm not putting anything. So divided by, let's apply the same thing. Minus, because of the first boundary will be vanishing, right? So I can also write like minus 0 over 0, which will be in the first boundary when you take the derivative. Cosine x in the second boundary, so minus e to the power square root of cosine x minus t, cosine x minus 1, pardon, and dot the derivative of the function. Let me put myself here. Oh, okay. So, derivative of the boundary. What is the derivative of the boundary? Minus sine x. So dot minus sine x. When you simplify, it is limit when x goes to 0. We have a lot of minus sign, one here and two are here, so it is minus sine or 2x sine x to the power 4 over e to the okay, sine x dot e to the power square root of cosine x minus 1. So let's again try to analyze the behavior of the function around 0. When you put 0, this is 0, this is 0. So maybe how? When you consider this thing, okay, so it will have a limit 2, right? Because of x over sine x will be 1 and we have 2. That's why this limit will be 2 when x goes to 0. Because since limit x goes to 0, sine x over x is 1. When you invert them, x over sine x is also 1. So what else? Now when x goes to 0, this part becomes 1. So square root of 1 is 1, e to power 0, which is 1. And this is 0. So this whole limit will be just equal to 2 dot 0 over 1. Okay. Let me put e to the power 0 instead of 1. So this is just 0. So since limit exists and 0, so this L'Hopital rule actually applies, and my original limit is has the limit 0. Okay, so let me copy and paste the next question. Oops. Okay, şöyle yapacağız. So this is a linear approximation problem. Okay. Oh, let me put myself here. Okay. Let's solve part A. Okay, determine the linear approximation of the function at 1. Linear approximation is just a linear tangent line of the function at the point, at the given point. So let's calculate. So linear approximation function or the tangent line at x equals to 1 is given by uh, let me put Lx is equal to f of 1, because we are looking at the point 1, plus f prime 1 x minus 1. So what is f1? When you put 1, you get 2 plus 1 1 cosine blah blah blah. Since boundaries are the same, it will be 0. So it is just 2. What about f prime 1? So it is by fundamental theorem of calculus, it is cosine 37 x to the power 4 minus 1 dot the derivative of the boundary, which is 4x cubed. Okay, minus 0, because the second boundary is constant. It doesn't change with respect to x. So that's okay. Now, if you put values back in this linear approximation function or tangent line, Lx then is given by 2 plus f. Okay, we need to also evaluate at 1, right? So they are okay, but when you put 1, so f prime 1 is equal to cosine 37 0 4 1 cube, which is just 4, right? Because cosine 0 is 1. When you take the higher powers, it is still 1, so it is just 4. Okay. If I didn't make any mistake, it should be correct. Yes. Yes, okay. Now it is my linear approximation function. So part A is finished. So let's do part B. With respect to this linear approximation function, approximate f 1.01. So it's just evaluation. Okay. So it is equal, not equal, but approximately L of 1.01, which is 2 plus 4 dot multiply by, 0.01. So it's just 2 comma, not comma, it's a comma diyelim, okay. 0, 4. So this is your approximation. So let's do the next question. Board 1. Okay. Now, let's say that f is a differentiable function and satisfies these two. Also, define a new function g with respect to or in terms of f, in terms of this given differentiable function, and say that this new function g has a critical point at 0, at 2. It means that uh, okay, g has crit point at x equals 2 means either g prime 2 is 0 or g prime 2 is undefined. I mean singular. Okay. So uh, I'm gonna just make this second condition disappear. How? So if this g prime 2 is undefined, what happens here? When you put x equals to 2, you cannot put x equals to 2, I mean. Okay, that's the problem. So first let's try to understand the g prime. Take the derivative. Then we will see that this is not happening. So g prime 2 must be 0. So let's try to understand. Apply product rule. Minus 1 over x squared. Integral 0 x f t dt plus 1 over x. Uh, Also apply fundamental theorem of calculus f of x. Okay. When you take the derivative of this integral, you get just f of x because with respect to derivative with respect to x of x is just one. So let's also, do we need to simplify? No. So it says that g prime 2 not defined, or is it defined? Let's check. When you put 2, this has no problem. This has no problem. And if it's differentiable and has a value at 2, so this is definable, right? This is defined. And this is also defined. This is even differentiable, right? This is even differentiable at 2. So everything is defined. So G2 is defined. So this must be, okay, this is not true. So G prime 2 is 0. When you just plug here G prime 2, you get minus 1 over 4 integral to 0 to 2 f of t dt plus 1 over 2 f of 2. So we also know the value of f2, which is 5, right? So we have, this implies f of, no, integral 0 to 2 f of t dt is equal to 4 to 10. It must be 10. So it is my result. We don't actually care about this. I mean, we care about, it's not the solution, okay? We need to determine the critical points. Either it is local maximum or local minimum. So we will determine gx, g2 is local minimum, local maximum, or neither. Okay? So it is a bit hard to investigate this critical point in terms of tables. So we cannot analyze. So is it positive? Is it negative? Okay, I mean G prime. So it is better to use second derivative test. So in order to do that, let's take the second derivative. By the way, it is probably possible by tables and first derivative test, but I want to apply second derivative test. It is up to you. There is no just one answer. So let's calculate then the second derivative of g. So this is my g prime, right? So this is my g prime. So let's calculate the second one. Apply product rule. I get 2 over x power 3 integral 0 x f t dt minus 1 over x squared. Here, what is the derivative of this? It is f of t, f of x, I mean, by fundamental theorem of calculus. Actually, again, apply product rule here. I will get the same thing, actually, right? Yeah, similar thing, I mean. 1 over x squared f of x plus 1 over x f prime x. So this is what happens when you take the derivative of this function. Mhm. So let's try to understand g prime prime x at 2. So let me put 2. So we have 2 over 8 integrals 0 to 2 f t dt. So here, so minus 1 over 4 f of 2 minus the same thing. So let me put 2 here. 2, or let me just erase it. Okay. So this is the same thing. So we have, and this one, 1 over 2 f prime 2. Okay. So let's recall the second derivative test. Second, if x0 is a critical point and f prime prime and f prime prime x0 is less than 0, then x0 is corresponding to, so this is concave down, so it should be local maximum if everything is the same, but f prime prime x0 is bigger than that, then to local minimum. Okay, now let's calculate our g prime prime x's, g prime prime 2. We have already written there. So the only thing unknown is this integral, but we have just calculated, right? This is 10. By the way, what was the f2? So let me check. f2 is 5, f prime 2 is minus 3. 5 minus 3. This is 5. So this is minus 3. When you plug them and sum them up, you get 1 over 4, 10 minus 10 over 4 again, right? So this is also 10 over 4. So I get minus 3 over 2, minus 3 over 2. So what do I get? So they are just cancel. I have minus 3 over 2, which is less than 0. So then x equals to 2 is a local maximum by second derivative test. So we have classified, right? It was the classification problem. Classify the point x equals to 0. So we have just shown that it is local maximum. So let's solve the next question. Ha, there's only one next question, and these are all the calculation of integrals. So let me just, okay, evaluate integrals part A. Böyle olur. That's good. So we are just going to apply whatever we know. There are exactly not one answer, not only one answer, not unique answers. You can solve whatever the methods you have learned. So these are just possible ones. So when you consider the denominator as a variable u, what happens? When you take the derivative, you get 2x plus minus 2 sine x. It's exactly the amount multiple of the numerator, constant multiple of the numerator, so it will get me some logarithmic integral. So try u equals to x squared plus 2 cosine x. When you take the derivative of both sides, 2x minus 2 sine x dx, right? Mhm. Now, when you plug them in, so this is just numerator, right? The right hand side is the twice of the numerator. So we get, let me call this integral as I. Okay, then so I is equal to du over 2 over u. So this is my u, this is du over 2, so this is just 1 over 2 du over u. So this is just ln u, 1 over 2 ln u plus constant. So we don't know the, so in this case, actually we don't know. Yeah, it's actually it is positive most of the times. Yeah, because it is bounded by minus 2 and 2. So between, I don't know, it takes a lot of time. So it's better to put absolute sign, okay? So because ln is only defined for positive values or positive variables, okay? Positive real numbers, I mean. So put this. But the original integral was in terms of x. So what is this new variable? So you need to put back the old substitution, okay, old variables. So this is actually equal to 1 over 2 ln square root of x, not square root of absolute value, x to 2 cosine x, pardon, plus c. So this is finished. So let me take another integral. Böyle almayacağım. Let me take 2 by 2. Part B and C. Okay. So let's solve part B. So e squared dx over x ln x. If you consider, okay, ln x as a u, so what is the derivative of ln x? It is dx over x. So as you can see, it is again du over u. Okay, so put u equals ln x. We get du is equal to dx over x by definition of the derivative of ln x. So then this integral I is becoming, or I becomes integral du over u. What about boundaries? You need to also change the boundaries. When your x is e, you need to put back in your substitution. So this becomes u becomes ln e. What happens? It is 1, right? When you put e squared, then it becomes 2. So it is your boundary. So what is this integral? It is just ln. So by fundamental theorem of calculus, by Fed. Yeah, sometimes we don't write them, or sometimes we don't recall. It's fine. But all these are happening because of the fundamental theorem of calculus. Okay. So ln u, since it is defined on positive values 2 and 1, It is just ln 2 minus ln 1. By the way, since your integral is definite one, when you change the variable, you don't have to go back to your original values because you also change your boundaries, so it is the same integral. Okay, so that by the way, ln1 is 0, so it is just ln2. Part C, so tangent. So since it is ln something, I want to make this u. Okay. Then we know that tangent is sine over cosine, so we will have something like u. And what about sine? It is du. So we will at the end we will have some ln du over u or something like that. So let's check. Put u equals cosine x. So du, it is just observation, okay? These are just observation. Du is equal to minus sine x dx. So what about this integral? So integral becomes uh, okay. Let me just first write this integral as sine x over cosine x ln cosine x. Mhm. Now this I becomes minus ln u. Instead of sine x dx, I'm just gonna put minus du. So this is du over cosine x becomes u, so this is u. The same integral, very similar integral to the part B actually, because now you must do another change because du over u becomes your dv if you call your ln u as your v. Okay, because derivative of ln u is du over u, so it is just v dv. Okay, now define again v equals ln u. Okay, now dv is equal to du over u. So your integral becomes minus v dv. Okay, so it is very easy to calculate, which is just minus v square over 2 plus some constant. Now it is not finished because it is in terms of v, whatever v or u we will put back. So it is just minus ln square u. Actually, it's absolute sign. Ln square u over 2 plus c or is equal to minus ln square. What is u? U was cosine x. Over 2 plus constant. So that's all. Again, let me take triple parts. df. Mhm. Yeah. So d. You can consider this integral. You can rewrite this integral like the following. Let's make this integral x sine 2x over 2, right? Because sine 2x is 2 sine x cosine x, etc. So the point that I am writing this like this because of I want to apply integral by parts because I want to get rid of this polynomial x, and I will end up with this sine 2x, which is very easy to calculate. So by parts, right? So first recall the by parts. Recall integral by parts. So this is not actually very good, but okay. uv prime is equal to uv minus u prime v. So there are dx dt over. But this is like a memorizing tool or memorizing form of integral by parts. It's basically the product rule. Okay. I mean, the product rule, all the derivatives, you take integral of each side, etc. Now let's apply this integral by parts technique. So I'm just gonna call my u this part. Okay, let me do it in red or blue. So let's call this is u. Let's call this is dv. Okay. So du is 1. V is just minus cosine 2x over 4. Because when you take the derivative of v with respect to x, you get minus again because of the cosine and the derivative inside, which is 2. So you get the original thing. So it's correct. So now it's the integral. So integral is then equal to uv, I mean x, and minus cosine 2x over 4, and minus integral this minus cosine 2x over 4 dot the du, which is 1. So 1 dx. So now it is very easy to calculate this cosine x, right? So but let me just first simplify it because it is a bit confusing. Minus 1 minus x over 4 cosine 2x plus integral cosine 2x over 4 dx. So now this is which is equal to minus x over 4 cosine 2x plus 1 over 8 sine 2x plus c. Again, you can also verify this by taking derivative of this function. When you take derivative, we get 2 and cosine, so you get the same thing. So this is part D. So let's calculate part E. So again, I want to make this ln x as u. So put u is equal to ln x. Take the derivative, very classical. So it is dx over x. When you plug the values, okay, let me call this integral g and let me call this integral k. Okay, so the integral j becomes from something to something we will calculate sinus ln x or u, and instead of dx, I'm just gonna put x du. Uh, so e to the power u is becoming x. So x du is equal to eu du, okay, which is equal to dx. Right here, dx is equal to x du, so this one, and x is equal to e to the power u because of this equality. So the whole integral becomes sinus u, and instead of dx, I'm just gonna put e to power u du. So this e to power u du. What about boundaries? So since I make this a bit messy, okay, let me move it. So what are the boundaries? By the way, let me also delete this part. Ah, so the boundaries is when you put x equals to 1. So what happens to your u? When you put x equals to 1, u becomes 0. When you put e, ln e becomes 1, so it is 1. So this is now your integral. So you can calculate it by doing something, but there is no specialty about the boundaries that makes the calculations easier. So let's calculate the antiderivatives. So let me call h x equals to integral e to power x sine x dx. So now apply integral by parts. This is e to power x sine x is very special integral actually. You need to apply it for twice of the integral by parts. At the end, you will find some symmetrical things that will, give you the result easily. So let me just apply integral by parts. So let me call this as a u. It doesn't matter actually in this case. It is dv. So what is your du? Du is e to power x dx. I mean, e to power x is enough actually. Yeah, anyway, let me do it precisely. So when your dv is sine x dx, what is your v? It is minus cosine x, right? V is equal to minus cosine x. I'm not putting minus plus c's, etc. The original function is enough because at the end you can put plus minus signs and your integral will be definite, so they will cancel. So in the integral by parts, we don't put this plus c's. They don't make any sense. I mean, they make any sense, but at the end they will just contribute as a constant. So you can just put the constant at the end. For example, recall the previous part D. We apply integral by parts. We don't do any v's or do c's here. We just put at the end. Okay, that's enough. Anyway, let's continue. So your u becomes e to power x. So it is e to power x, not becomes. So v is just minus cosine x minus. So we have minus 1 minus cosine x e to power x. Okay, dx. So it is not finished, right? So let's calculate now now calculate similarly e to power x cosine x dx. Again, call this as a u, this as a dv. So your du is e to power x dx. Okay, this is u. So your v becomes sine x. So it is just e to power x sine x minus e to power x sine x dx. As you can see, you try to apply integral by parts, but it is a loop, right? You get the original integral. So we first, let's go back. We need to apply integral by parts to this function. So we get this function, but it is just e to power x cosine x, right? This one. So when you again try to apply integral by parts, you get the first integral, e to power x sine x. So but it's not very bad. It's not very bad at all. Just put back the values. Okay, put back. So let's see what happens. Now your h of x, not h of x, but okay, let's just put e to power x sine x dx is equal to minus e to power x cosine x plus this integral e to power x sine x minus e to power x sine x dx. So these two are, what did we call? We call them h of x. This is also h of x. So at the end, so 2h of x is equal to, right? I'm just putting this in the left hand side, e to power x sine x minus cosine x. So when you divide by 2, so your integral e to power x cosine sine x dx is just this integral 1 over 2 or e to power x over 2 sine x minus cosine x. Okay. Now, what was our original integral? It was zero, from 0 to 1 uh, sine u eu. So we have just calculated its definite integrals or antiderivative. Indefinite integrals, I mean. So this g is 0 to 1 sine u e to power u du, which is just e to power x, or let me, e to power u over 2 sine u minus cosine u, and your boundaries is 1 and 0, so just put the values. So what do you get? 1 over 2, it is in the bigger parentheses, e to power 1 sine 1 cosine 1 minus e to power 0 sine 0 cosine 0. So this is your result. Yes. So part F. Let's do part F. Let's have it big. Mhm. Uh, Again, without checking anything, you can put this as a u. So u is equal to square root of x. Take derivative of both sides. You get dx over 2 square root of x. Mhm. So I want to calculate the x, right? But in terms of only u, so this becomes, so dx becomes 2 square root of x du. So instead of square root of x, I'm just gonna put u. So it is just du d şey 2u du. Okay, when you plug into integral, we just call them k, the integral. So k is equal to integral cosine u and 2u du. Again, it's just a polynomial multiplied by a trigonometric function. So let's do integral by parts. Let me call this part uh, u, okay, bigger u, okay, or any other word. Let me call it m, and this cosine and du, d, dn. So n becomes now sinus sine x, and dm becomes 2. So this integral k by parts, this this integral k becomes the next integral by parts, integral by parts, n m 2u and sinus x minus uh, sinus x to dx. I know this integral of sinus x, which is minus cosine x, right? Well, we get another minus. So this integral is then 2u. By the way, u just square root of x. So 2 square root of x. Ah, by the way, this is not x, this is u. So this n becomes u. There is some typos. Uh-huh. So this is also u. So this is also u. But this is correct. This is just dummy variable, but you don't have, yeah, you need to remember what is u or not. Okay, this is 2 square root of x sinus square root of x minus the integral of sine, which is minus cosine. So it is cosine square root of x. But let me just clear them. Okay, nevertheless, this is u, this is the u, this is again u. So we have two also. Huh. Everything is in terms of x, and you need to also put your plus sign, plus constant because you don't have any boundary. Okay, this is your result. So let me again calculate another one. We did f. Okay, let's do g. Mhm. Let's do part g. So this is your integral. When you put u, okay, then du becomes 2x, and there is something also, etc. So let's just try to make this work. Okay, let's u, let's do u equals x squared plus 3. Now, by the way, then x square also u minus 3, but it's not important. Now, it will be important. And du is 2x dx. And okay. So now let me call this integral I, let me call this integral j. Okay. So I becomes some boundary. When you apply this substitution, what happens? When x is 0, then u becomes 3. When x is 2, u becomes 7. Okay. 4 plus 3. And your 2x dx becomes, okay, you can borrow 1x from here to here. Okay, you can one, so it is just x to the power 4 dot x. So you can borrow x to here to get this form. So what do you get is x to the power 4, I mean u minus 3 to the power 2 dot square root of u, and we just borrow 1x, so we have du over 2 because du over 2 is x dx, and we just borrow 1x from here to make it x dx, so this is correct. So we can also calculate this integral as it is just a polynomial. Okay, you can write this square root of u as u to the power 1 over 2. And you can expand this by u squared minus 6u plus 9. If you multiply them, you get just u to some powers. And integral is additive, so you can just separately calculate these integrals. Anyway, let me do it. From 3 to 7, your integrand is the multiplication of these two. So it is just u to the power 2 plus 1 over 2. It is 5 over 2 minus 6 to the power 6 u to the power 3 over 2 plus 9 u to the power 1 over 2 du. Of course, we also have 1 over 2 here coming from here. Okay. Now, so let me just calculate it. Calculate it. It's just increase the power by 1 and divide by this increased power. So it is just u to the power 7 over 2 over 7 2 minus uh, u to the power 5 over 2 over 5 and 12 plus u to the power 3 over 2 3 and 18. So you just need to evaluate at 3 and 7. Okay, put 7. Okay, let me call this function as h of u. So this result is just h of 7 minus h of 3. Okay. Let me do the part H. So this integ, okay, we have arcsinus x. Do we know what is the integral of arcsin? Probably to be able to say this, you need to apply integral by parts again, right? In this case, it is no, like loop. So that's why we need to get rid of it because we know that the derivative of arcsinus x is just rational function in terms of x, some polynomials, etc. Right? So, and I know the integral of x squared. So let's make this like following. Let's call this is du and let's call this v. Okay. So what happens? Now u becomes x cubed over 3 and dv becomes 1 over square root of 1 minus x squared. Okay. So integral by parts is equal to by parts. So it is just x cubed over 3. So what is your v? Your arctangent arcsinus x minus x cubed over 3. So this thing, 1 over square root of 1 minus x squared dx. So let us simplify. Okay, this is finished. So I need to only calculate this integral. So let me check, did I make a mistake or not? No, okay. So let me call again. So make some comma and calculate. Let's calculate integral x cubed over square root of 1 minus x squared. So let's make the substitution u equals 1 minus x squared. So du becomes minus 2x dx. Mhm. Now, what happens to this x cube? X cube is just x uh, square and x. So one of the x would go to du, and the other x square will be 1 minus u square. So this integral becomes equals to uh, x dx. So minus du over 2. This becomes this. And we have another x squared. X squared becomes 1 minus u squared. And at the denominator, we have square root of u. So let me simplify it. So it is just integral minus 1 over 2 at the beginning. So 1 minus u squared du over square root of u, which is again very easy to calculate because this is equal to minus 1 over 2. Um, just expand this integral u to the power minus 1 over 2 du minus integral u to the power 2 minus 1 over 2. So it is 3 over 2 du. Okay. So this u square root of u is just actually u to the power 1 over 2. So you can write it like that. So you can calculate it. So let's do it. Uh, so g is equal to x cubed over 3 arcsin x minus 1 over 3. So it is just minus 1 over 2. So what is this integral? It is just u to power 1 over 2 over 2. So it is 2 u to the power 1 over 2. So this is just u to the power 5 over 2 2 over 5. Okay, so this is 2 square root of u minus 2 over 5, u to over 5 over 2. Mhm. But of course, what is your u? So u is equal to, by the way, 1 minus x squared. So when you plug the values, it becomes this. 1 over 6, 2 square root of 1 minus x squared minus 2 over 5, 1 minus x squared, 5 to the power 5 over 2. Plus constant, because I don't remember, but it should be, yes, it is indefinite integral, so you need to put plus c. Okay. I don't think there's some typos, but if there is some calculation errors, you can always notify me in the mails or in the comments. So let's solve three more and we are finished. This is I. Oh, now, this is equal to integral by parts, right? I want to get rid of this polynomial. So let me always systematically call this u, and this is dv. So what becomes du becomes 2x dx. V becomes just integral of it, which is very easy, e to the power 3x over 3. Okay, so this is equal to uh, x squared e to the power 3x over 3 minus integral 2x e to the power 3x over 3 dx. Okay, now again, now calculate x to x e to the power 3x dx. Now this is comma, so I'm calculating this integral. Okay, now calculate. Let's calculate. So again, integral by parts. U dv. So du becomes dx. So it means 1. V becomes e to the power 3 over x, 3x over 3. So this is just x e to the power 3x over 3 minus integral e to the power 3x over 3 dx. So this is also another integral. It is very easy integral. So this is at the end x over 3 e to the power 3x minus 1 over 9 e to the power 3x plus some constant. Okay. Just plug this integral here. So we get minus 2 over 3 of this integral. So at the end, therefore, if this integral is I becomes, by the way, we just calculate indefinite integral shape. In code. We just calculate the indefinite integrals. So they are not equal. So this is equal to, so let me do it. Ah, this is equal to without boundaries, x squared e to the power 3x dx. Okay. Without boundaries. When you put the boundaries, so what do you get? You get, by the way, first let me just write this integral in this clearer form. So for integral x squared e to the power 3x dx is equal to, x squared e to power 3x over 3. This part. Now this part. This means this integral. Okay, they are equal. So this integral is equal to this integral, and this has the answer this. Okay, so it is just minus this part x over 3 e to power 3x minus 1/9 e to power 3x plus some constant. Okay, this is my integral. By the way, I forgot to multiply and forget about the signs. So, first of all, this should be positive, and there should be some 2 over 3's also. Because, yeah, so this 2 and this 3 and this minus sign shouldn't be forgotten. So, so this integral I with boundaries is just equal to, I don't know, just put the values, okay? So this is your function, but maybe I can do extra as simplifying it more better in more better form. E to power 3x over 3. Okay, this is just x squared minus 2x over 3 plus 2 over 9. Okay, plus. I'm not sure. Yes, this should be 3 by the way. Uh, no, correct, correct. That's correct. Okay. When you put the boundaries, you will answer. You will get your answer. Okay. It takes a lot of time. Should be trivial. Let me solve these questions. Mhm. Okay. So let me call this integral I. Let me call this integral j. So let me call the integral part j. So uh, huh. First, try to understand this integral. Secant cube x tangent 5x. Just expand this tangent and secant. 1 over secant means it is 1 over cosine, so it is 1 over cosine cube x. Tangent means it is sine over cosine, so we have sine 5x over cosine 5x. Did it help? I'm not sure. Mm, it actually helps. It actually helped. Okay, there are two methods, I guess. In this form, I can also rewrite this as uh, sine 4x over cosine 8x dot sine x. It can be also written as 1 minus cosine square x square over cosine 8x sine x. Okay, it means that if you put your cosine x as u, then this is your du, so your integrals is finished. Okay, this is method one. So this integral becomes this uh, 1 minus cosine square x square over cosine 8x sine x dx. Put u equals cosine x. It's substitution. Du becomes minus sine x dx. So it is just minus integral 1 minus u square over u to the power 8 and du. And it is it easy to solve? Yes, it is very easy to solve because if you expand this inside, minus integral. Okay, let me expand for you. This is 1 over u to power 8 or u to power minus 8 minus 2 u square over u8 plus u to the power 4 over u to the power 8 du. So this is very easy to calculate. It is u to power minus 8. It is u to power minus 6. It is u to power minus 4. Everything is very easy to calculate. In method 2, so it is method 1, you can write secant cube x tangent. I'm not sure. I'm just feeling it. I forgot about the solutions. So I know that the derivative of tangent is secant square. Derivative of tangent is secant square. If you call tangent x as a u, then secant x. No, it's not good. But if you call secant x as u, then the derivative of secant x is secant x tangent x. And yes, okay, let me just write them like this. Secant x tangent x. Okay, dot secant square x. Then tangent 4x. Okay, I can write them like this. And recall that 1 plus secant square x. I mean, no, not true. Tangent square x is secant square. So instead of tangent x, you can write secant square x minus 1. So you get rid of this tangent, and this is your du, and this is your polynomial of u. Okay, so it will be okay. Let me rewrite again. Secant x tangent x. This is secant square x, and instead of tangent x, I'm just gonna put secant square x minus 1 square. So if you put your u as secant x, and you know that your du is secant x tangent x, so it becomes du, it becomes u square, it becomes u square minus 1 to the power 2. Actually, similar thing. Not similar. Yeah, there's very big difference. But you can actually, calculate in this way. Okay. So let me also show you how to take the integral. So your integral is now uh, like I did everything actually. U square minus 1 square du. If you expand it, it's a polynomial. It's a polynomial. So it is very easy to calculate. You should definitely do it. Exercise. It's polynomial exercise. Okay. And you can compare that this integral and this integral has the same solution plus some constant. Okay, plus some constant. There should be some constant difference. Okay. Okay. So what else? What else? Just one more question. Uh, Let me copy and paste. Okay. Okay. Similarly, maybe it is very. Let me expand this. Okay, it is actually sinus cube x over cosine 5x dx. So now you can rewrite that as tangent cube x secant square x dx. Now it is very easy done, right? Because when you put let's say u is equal to tangent x, then du becomes secant square dx. So this is here. This is your du. So this is your u cube. So this integral is just u cube du. So it is u to power 4 over 4 plus constant. But it's not finished. You need to put u back. Tangent 4x over 4 plus c. Okay. So it is finished. If you have any question, please comment. Dur, bak.